you all for coming out here. Coming to talk with as many buzzwords in the subtitle as Memcached, so I'm glad you all decided to give that a go on Tuesday morning. I want to say you all look absolutely fabulous, and I hope you have a good time here. Alright, so what are we going to try to do today? Basically, so this is my axe friend. I don't want to be upfront about it and tell you what I'm hoping will be coming out of this. We're forming some working teams at my office, and we're trying to sort of figure out what the makeup of, like, who should go into teams, like, who should be deciding on project decisions get in. So, product person, a design person, an engineer. We're talking about the roles that all those people have. And someone's like, oh, we need an engineer there, so they can be sort of the break, right? So we don't get too many crazy ideas. We need an engineer, so that this sort of slow things down. And that did not make me very happy. I think that there's no way for us to win if we are sort of engineering is seen as sort of the break on innovation in our companies. So I really don't like that. But the fact is, we are also responsible for keeping the web servers going and keeping the site up, all those kinds of things. So it's really important to me that basically, at work, I've found I've noticed sort of a pattern of wanting to be able to try and do really hard stuff, very complicated stuff, and more specifically, really slow code that does awesome things, but is sort of firmly in the innovation space. And I think it's been difficult. There have been some projects that we have sort of avoided or not known how to do because we have very sensitive performance concerns about them. And I think my goal is to try and make it easier to innovate, do really slow stuff, get it out there quickly, see whether it actually works, and then later refactor and actually build something that is scalable, really works well. So, what I'm going to go over is basically Patella is just sort of a technique for trying to sort of do these things, innovate safely. And also involves a bit of meta programming, and that was certainly caused some uncertainty among some of my coworkers. It's a little different, so I think I'm going to try and actually dive into the nitty-gritty of that and sort of give people a little bit more of a comfortable feeling about some meta programming stuff. So hopefully you will get to learn something about that too. All right. So I'm going to try and write this up sort of going from like the problem statement, trying to explain what I'm talking about, what the sort of general problem I've seen is, and then kind of sketch out a solution, figure out what the solution space is and what kind of solution we're looking for out of this. And then we're going to get into the nitty-gritty details. There is a gem on GitHub of all this code. It is not what we are actually using in production. Yeah, I would classify it as total alpha gem. So I think the reason we're going to code, it's really not that much code or that much work. So I think it's more important to understand what the heck we're trying to do more than I'm not trying to like hawk my gem or something. No, we're not using production, so don't go run out without it. You don't use it without understanding it. Okay, so I'm going to go over a couple different problems where I sort of saw this pattern where I wanted to write slow code and didn't want to have to worry about scaling. The first one is this. There's a National Institute of Health presentation that the chairman of the board, our sort of visionary entrepreneur fellow, was going to go present in 4 weeks. And I'm sure this never happens to you guys, but he had the idea that he would like to announce a major integration with the clinical trials government website where we're going to pull down their data and we are going to match it with all of our patients that are on our website. We're going to find which clinical trials they're eligible for. We're going to match over clinical trial type and phase. We're going to do some sophisticated matching across some medical ontologies so they keep track. They say have multiple sclerosis in one ontology, we do it in a different ontology, we have to sort of bridge those gaps. And then the main sort of, this other trick was he was very fired up. We were going to be different than everybody else. We were going to have really detailed matching based on the locations of patients to their clinical trial. This is the theory, the hypothesis being that a lot of people aren't entering trials perhaps, and the matching is very difficult because some people need a clinical trial, they can't drive across the city or can't drive across it really distance matters. Okay, so what is it going to look like? Well, this is sort of the interface we're headed towards. So basically you say, I have multiple sclerosis, I'm female, my age, my zip code, all sorts of other things, and you can drill down by phase and type, all these kinds of things. And we're going to then surface clinical trials that hold by distance and all that. So that's great. So we don't really have any of the technology in place for this. We have a choice, right? And so we also have a choice to get amazing tattoos and Harry Potter books on our back, which I would read that the reader request. It says we must all face the choice between what is right and what is easy. And so what would be right? Like, what is the right solution to this big solution space here, right? You're trying to search across huge swaths of clinical trial data, and you're trying to do this location search. So we're on Postgres. There is something called PostGIS, which is great spatial database extension from Postgres. That's great. They're getting the button to install, and I just sort of didn't want to do. I was hesitant to do that because I wasn't really sure exactly how important this problem is. The whole problem is itself. That was a perfect fit for Mongo. It really sounded like a Mongo kind of problem. We sort of wanted to do that too because it's got the spatial stuff in there, and it's just sort of you can really do these clinical trials like as if they were big documents, and you're just doing this sort of massive document search with location. Okay, what was easy was this. We're just throwing this right in the SQL statement right here. So this is this crazy little equation that actually converts from lat and longitude to distance using sort of approximation, and it is actually kind of good enough for government work, I suppose. Actually, most clinical trial government stuff. Kind of work. But and then so that's quite a SQL statement there. And I'm gonna write. So there's the right solution, and then there's this easy thing, which you can write pretty quickly. That was great. And I say choose the easy. You have this choice. See, look, they can all live happily together, right? And this is one big happy family here. I bring you a message of joy and peace. You can write all this code you want here. Well, why do that? Why not install Mongo and do this thing right? Well, who knows if location is even? Oh god, there we are. Who knows if location is even important, right? This is a hypothesis. We're doing this in 4 weeks. We get a lot of ideas out of our work. Some of them are not great. So who even knows if this is important? Who even knows if this whole project is important, right? This is something we dreamed up for this presentation, and I don't even know if this project is going to live. I want to be able to kill this project if it doesn't actually work. And if we invest in setting Mongo, we're going to have to add it to all of our automated stage setup, production, monitoring. I have no problem doing that. But if I do all that and then we decide it's a bad project, I'm going to have to kill all that, and that would make me very sad. And I think that fundamentally affects the way we look at an experiment. If you know that you're going to have to rip out a bunch of stuff, so I don't want to do that. The fact of the matter is that little SQL query back there had quite a query plan. So it wasn't the worst thing I've ever seen, but it was not particularly pretty. It was sort of the Death Star query coming through your poor little Alderon server there. Okay, so it was definitely slow, and it was not effective to do what to do. So let's look at another one. We're a site called Patients Like Me, so part of the idea is that we have a really good way to match patients to other patients who really like them across all the dimensions you can think of. So we actually didn't do a great job of that. We had a bunch of search tools, so if you knew what you were looking for, we let you search across a whole bunch of things. But what we really wanted to do is just be like, you know what, this is the person most like you. Our site is for people, right? We have a serious illness, MS diagnosis. We want to find somebody else who's just like them, taking the same treatments, having the same side effects, same age, maybe we live in the same spot. But which we just want to go, here's the patient who's like you, and we want to be able to sort that out really intelligently. So it turns out that's not really actually a search problem, that's really a ranking problem. Search is when you're trying to filter a set of things. But what we're really doing is we're trying to do a similarity matrix across all our patients, right? We're trying to say, well, who is the person most like you? And really, we have 100,000 plus patients, n squared over 2 because your my similarity is the same as your similarity to me. Still, at about a byte per similarity, that's about 4 terabytes of data. N squared is no fooling. So we wanted to do this forever, but it was not clear what the solution was. We were going to have to do a bunch of engineering. And then I just wrote it up in Postgres, and it was amazingly valuable. It worked. And it was elegant. It is beautiful. Here's a bunch of, this is what I really wanted, right? Was just a whole bunch of different dimensions. I don't know just how able you are to see these. But basically, these are weighted dimensions, right? So I've got a whole bunch of comorbidities, you've got a whole bunch of comorbidities. We're going to take those sets, do a card similarity, figure out just how similar we are across comorbidities. We're going to do the same thing about your age. We're going to do the same thing about your distance. We're going to be able to weight all those little factors. It's going to be great. And you know what? It was even lovely sequel. It was beautiful. It made my heart sing. We've got the nicely little weighted factors, and all these ranking things come together very nicely. And it actually wasn't all that non-performant, but it was just this side of real time, right? Half a second, second and a half. Sadly, that just doesn't fly. You just can't actually release that to production because you've got 16 workers. If they all are spending a second or something doing your amazing query, you're starving, right? No one else can do the second, and that's sad. So I could have difficulty actually getting this in production because for very reasonable concerns, our ops guy was not excited about bringing down the website. But I really wanted it. So let's talk about sort of what the patterns are that I'm trying to describe this pattern that I'm seeing, right? There are, in general, always going to be crazy things like a forward-looking time machine, right? Like who would ever come here and be like, you know what, we're going to build a forward-looking time machine, and right? I mean, that's just crazy. I'm sure you guys never have your entrepreneurial leaders never come to you and you know, promise that they're going to be able to do a forward-looking time machine, right? Well, here's the chairman of the board of our company up on stage on 10 Bad promising a forward-looking time machine. So I'm sure you guys have had similar experiences where you're like, wow, that's great. I wonder if you asked anyone how we were planning to build that before we told people we could do it. Right, so I'm sure this never happens to you guys. But the question is, as an engineer, right, I want to be able to say, yes, let's do that. I don't want to be the brake on innovation. A forward-looking time machine sounds like a great idea. I would like to be able to make that happen, but I would also like the website to still run. So I want to be able to give him, I want to be able to sponsor innovation like this, and it's just hard. And I want to be able to do it really easily. So stepping back, the general problems are like, so we're trying to capture medicine, right? It's a massive database, super relational, and it's getting bigger and bigger. It's extremely complicated. There are no sort of easy solutions to this space. The relational model is the correct one, but it turns out like relational queries just don't necessarily scale. They can be the best, most efficient way to query something, and it can still take a little bit of time. And you just can't write indexes to get way out of it. And honestly, I'm not really talking just about SQL. I'm talking about pretty much anything where there are really awesome things you want to do in this one. And I think it should be easier to do those things. So there are, you know, the way to do it when you actually can use scales, right? You know, you denormalize some queries, you do all kinds of novel stuff, you write a total special custom solution. The fact is, I don't think that's really enough because there are so many ideas you want to experiment with, and you want to try, but you don't know whether they're going to be good. You can build a whole custom solution, and then you have to prove it out. You're going to do real stuff. So I want to do that, but I also don't want, this is Winfield, this is the ops guy at work, and you can see he's got a nice little goatee there, and so we have he's got a character, right? So we have a specialized emoticon for him, which is this. This is Winfield face. This is the sad face he makes when I try and burn out servers. We've sort of taken this to another level. We actually made a cake of his face. So what are we going to do about this thing? All right. So what do we want? We want. So we're now in the sketching the solution section. All right. What do we want? I want a trivially easy way for developers to declare that some methods are just not safe. They are not to be run without full supervision. You should not just call them because in the request lifecycle. The other thing I want is I want a consistent framework so that I can tell my ops guy, it's like, hey, don't be afraid. Don't be afraid. I wrote something that's very slow, but it's going to be fine. It's using this consistent framework that you all have familiarity with, and there's going to be some more workers and stuff, but like we're not going to just starve the website so it can't process requests. All right, so what kind of solutions are there? I already said this. I really just don't think it's enough. I'm doing it right. Doing it right is just not an option. This is my sort of general thesis. It's too slow. It's too expensive. It slows innovation. You have to be able to experiment with these things another way. How many people know what memoization is? Yeah. Right. So memoization is brilliant, right? You learned about memoization. It basically means you can call it's functional programming nirvana, right? Every single method is can be called with whatever arguments, and it's going to get cached forever, and that's great. That's exactly what I want. I want slow methods that then build upon each other and return very quickly. And there's memoization in Rails. That's great. The only problem is it only works in a single request, right? If you call the same method 40 times in a request, that's great. It's going to be fast on the next 39 requests, but I don't do that very often. Mostly it's across request things, and so memoization doesn't really work all that often in the standard web app. So what else is there? Right? Well, there's Memcached, and that's great. We always Memcached, but it's super simple to set up. You have to do some handmade keys, which I always find to be a little annoying. Feel like, why can't I figure this out for me? Because I like memoization where you don't have to think about anything. Whatever arguments come in, automatically generate the key. But it doesn't solve Winfield's problem, right? Because the first request still slams the server with Memcached, right? All the other requests are going to be fine, but the first one in the standard Memcached solution does the cache batch, and it calculates things right there for you. So what do? You could warm the cache or something. You do a bunch of other things to try and alleviate this problem, but you're still going to be running a risk. You still cannot just put slow methods anywhere in the request response. You just can't do it. So we need to, something's got to give here, right? And I think the main thing is that we got to remove one constraint, or sort of flip the deal around here. So when we do Rails.cache.fetch, right, it guarantees us a result. It's super little block, right? So you say you're always going to get a result. It's going to go with Memcached, and then otherwise it's going to do it for you. So you are always going to get a result. But the performance characteristics of that are totally different, right? Sometimes it's going to be really fast, sometimes it's going to be really slow. So it's not great. It's not great. You can't have something that's really slow in there. So let's put that deal around. Let's have basically a cache batch thing that guarantees quick performance, right? It doesn't. Something's got to give. It doesn't actually guarantee that you're going to get a result, but it's going to be fast, right? So the basic idea is it's okay not to know the answer sometimes. All right, but we're going to need a name for this, and because it's Rails, we're going to need something sort of clever. So I was trying to think what we're trying to do. We're trying to say we're trying to develop a service that just gives you a response quickly, right? You ask it, it always responds, but it's okay not knowing the answer. It'll either give you the right answer or it'll say, I don't know. So I actually found this is amazing. This is fuck yeah nervous system, the Tumblr blog. I have no idea what else is in there, but this is what happens when you Google for Patella reflex, right? So Patella reflex is, this is just a catchy name here, but basically the idea is we're going to give you a response real quick. All right, so what are we doing? Technologies. So basically what we want the properties of memoization, which is like super easy. Just say, memoize this method, make it fast. But we want it to work across requests, so we want to put it in Memcached something. And we never want to actually calculate it in the request, so we want to kick stuff off with Resque. Yes? All right. So next up, we're actually going to get into some of the details of just what this would look like. So I'm going to start out. I like to think about, what is the perfect solution? What do I want to be able to do as a developer? And we're going to kind of work backwards from there, right? So here is sort of the middle one there, right? Let's say that method is really slow, because it is. It's assumption really slow. And what I want to be able to do is just like in memoization, I want to be able to say, cache this guy. I want to say, make this guy better. So I've got a method called report on that quick. I say Patella reflex report, and I'm going to give it an expiration right there. And so that's basically sets up the Memcached properties of it. And then what happens when I actually use this? Because the trick is this doesn't always have a result. What I like is when I call this method, I'd like to just get back whatever this method was going to return anyways. But then there's one other thing I'd like, right? I'd like to be able to solve, is it already loaded? And if so, I'm going to have to deal with the repercussions of not understanding the result. That's fine. I can go to Spinny and load it in Ajax. I can do all sorts of things. But basically, I want to be able to call this method, have a return really quickly, and then query, is there actually stuff in there or not? So that's the goal. So one thing, actually, this really dovetailed into Aaron this morning. Basically, so we had this thing where we're trying to get stuff out of the request cycles in a very easy way. And we found one of the stumbling blocks, I think, to actually using Resque very successfully is that you've got to write a worker for everything. And it's just a bit of a pain in the butt. And it turns out like all of our workers were just exactly the same, right? They pretty much just ran something. I mean, you don't really, in our case, we really almost never wanted any code in the workers. We wanted the code in models so they could be well unit tested, and we just wanted the workers to just kick off the method, right? We really had to do a bit of logging, a bit of sanity checking, but we just wanted to be able to kick stuff off. So we wrote this thing called send later, and basically this is just a super easy way to just do it later. It's like send, but it's do it later, and then it's going to keep going. And basically what that means is that we have a single worker for almost all of our background jobs that we need to do like this. It makes things pretty easy to, in particular in testing, and it's similar to what Aaron was saying about having a unified framework or UI for our developer UI, I guess we call it, for doing stuff in the background. We always do this, and we always know that it's all coming through this as well. So what does that actually look like? That looks like this. You see it there, that's how you call it. You just user and send later, the name of your expensive method, and whatever args. And all you're going to do is, this is sort of then a little mix-in to all our active record classes. And we say perform later, and you see we're figuring out what class and what ID something is, and then also passing on the method name and all of the args. So what this is doing is basically saying, once you've done this, any method in any of your classes is automatically sort of backgroundable, right? So what's it going to do on the backend to mention that word is this. This is our single worker, right? And so what it does is it goes and just looks up the object, and then it actually does a find, and then if it's, say you're in, user object number 7 or something, it just goes and looks up the user class and then does a find by ID of user 7, and then just calls send. Right? So this is precisely what it's described as. It's send later, and it's going to do it right in the context of where you started on. So this works both for a individual user record object or class methods. And I added some of the code to make it that shows how there's just some small tweaks to make it also work with class methods. So basically, anything you want, you just say send later. So this was sort of an existing piece of infrastructure we already have. It works great, so we're going to be using this. But that is only part of what we needed to do today, right? So we had that gets things calculated later. Great. But what we still needed, we still wanted our methods to feel like they were memoized, right? And we still needed something to automatically prove the Memcached, right? Okay. So the next step basically is to make that Patella reflex method actually do something. This is not a good slide. This is how I was like, oh great, I'll just show them the code, and then we'll just look at it for a long time, and that didn't seem like a great idea. So we're not going to do that. I was thinking of making us all sit here until we really understand the metaprogramming, but I think that's probably not a good way. So instead, we're going to go and talk about what is the object that I want to come back. We're just going to kind of step through this, and then come back to this to see why it's really not a lot of method going on here. So what is the thing that I want to return from my memoized method? Well, it's basically an object that just looks like what my method was going to call originally, but I can just query it. I can say, are you loaded? Right? Very easy. So very simple. Loaded, method missing. No big deal. We're just going to pass on everything to the actual object, the actual result object, and we're just going to have one more method on our thing that we sort of magically add inside. Great. So let's actually go through and let's look. What if we were just going to put up a single example so that it works like the way we want it to work, and we're going to sort of code it by name. What would that look like? And then we're going to sort of step back and show how the meta stuff makes this happen. Okay, so this is our slow method. All notifications for, right? This is, let me say, this is a slow thing. And all we want to be able to do, we just want to put this on, right? We're going to say, yeah, expire in 3 minutes. So this means we can, this is a method that gets called pretty much on every page load or something. And it's not that slow, but we want to speed it up and it doesn't change that often. So 3 minutes. Okay, so what do we need to do to actually make this work, right? Well, we're going to need to do this Memcached work, right? So I want the aspect of memoization. I don't want to have to think about caching. I don't want to have to do that. So we're gonna have sort of a unified cache key creation thing, which is basically going to take. We're going to need the name of the method, and we're going to need the arguments. That's how memoization works, right? Every method and all of the arguments forms a unique key. So those are the things that are keys to the generator is unique. The next thing is we're going to have to we're going to go to a fetch and we're going to see whether the results are already there, right? Because there's two ways this could go down. One is it was already cached, and you're just going to return it, and then you're going to return it, and you're going to say. And you're going to return the Patella result, and the status of loaded is going to be true. So one way of going through this code is it does the fetch, it finds it, and then it looks in there, and it does some JSON parses the results, and the last line there, not valid promise. If your result doesn't have this promise in it, then we figure, okay, it's great, the thing is actually been loaded. The other option is that it's not there. So what happens if it's not in Memcached? Well, what we need to do is we need to sort of we're going to say, hey, yeah, we promise we'll do it later. So what we're going to do is we're going to send later, and we're going to send later, which is that thing I showed you before, and we're going to send later a caching version of that original method, right? So we're going to have to actually we're going to go off the Resque and say, this is what happens. We're going to have to kick off a Resque worker that will generate the method as if we were calling it straight. Good. And then we're going to just return pretty much an empty object which just says, I'm loading. That's all. All right. So this is so the last bit here. I just added the caching notification version down there, and this is what is going to get called from Resque. Okay. So what the thing this needs to do, it needs to generate the same key. Using the name and the args, and then it needs to call the original method, which I call the Patella notification of redcam. So it needs to call the original thing. So this is the only way to actually call the original version of that, right? And then it just puts it in the cache. And then, so that will put it in the cache, and then the next thing that comes in is just going to find it in the cache. Going to be great. All right. Any questions on that? Glad you all understand. So now we're going to go back to that slide and just try and sketch out real quickly what's trying to happen here. Basically, if you go back here, you can see like all of this code is going to be really generatable in that this notification unread count method that is basically going to be the same for every single method that for any of these methods that we call Patella on. Basically, the only thing that changes is that the strings there are hard-coded, right? And the symbols are sort of hard-coded. So the only thing we really need to do to this in MetaMagick land is to generate this method with a different method name, right? So it's basically just we need to write that code and do a little string replacement on it, and that is what meta programming is all about, right? So that's basically what this is. We're just going to say we're going to write this code here. And you can see we're just doing string replacement, right? So we write the caching version of our method. And then we write the original version, which just calls the Patella version. And basically in all these places, we just insert the symbol of what we want to do. So that is really all that is going on in this slide. And it freaks people out because when you open it up in your editor, it all comes up as one big lump string instead of anything else. But it is not that bad. Is that where? Yeah, so that's just Memcached. I'll show you. That is so in this one you can see I call the original version. Is a original method. The very top line is a string that I call Patella thing, and then I do alias method. So that's where we get that one. Yeah. So we're just going to alias. So we want no one to call this method unless we want to protect everyone. Exactly. All right. He's nothing. Cool. So there are Memcached, and we're just going to kind of go over those here. Who's familiar with sort of the general dogpiling principle of caching? Dogpiling. All right, sure. All right. So what's a dogpile? Dogpile is guys jumping on top of each other. No, it's dogpiling is what happens when you've got a cache thing, and it's going to be kicking, and every hit to the cache, we're just going to sort of generate new stuff. And so basically, what would happen if our solution, if 1,000 requests come in 1 second to our, a naive solution would say, hey, that's great, I couldn't find anything in Memcached, so I started a Resque worker for you. Not great, because you're going to be 1,000 Resque workers all doing the exact same thing. Not what we want. So the trick is basically, you just need to make sure that you're only doing it once, and that until it's actually been created, you don't kick off more workers. So that actually happened in the code we already saw. And the key is that the fetch there always returns something after the first request. The only one that totally misses is the very first request. And the second request comes in, and the thing that gets put in Memcached is this little hash promise true. So that is just going to keep getting returned by requests. The first request is going to, and the first, second, third, fourth in our situation with 10,000 requests, those are all just going to return this little hash of, oh, I still have a promise, I still have a promise, I still have a promise. And then it's not until Resque actually runs the caching one, and it's just going to overwrite that. And at that point, we should only have one worker that actually gets fired off. Is that clear? I couldn't really, this isn't actually a dog pile, but this is the most amazing image result I ever saw. It's a bunch of dogs lining up, waiting. So I feel like maybe I was trying to capture the sentiment that our dog pile has turned into an ordered thing. And the metaphor doesn't try to work, but it's amazing. So a couple of Memcached, this one's pretty simple, but long arguments. I don't actually think this is a long argument. This is a different type of long argument. What I'm talking about is methods that take a whole bunch of args, and load up your cache keys. So this is just a simple trick. Obviously, if you have a huge amount of stuff and you want to make a unique short version of it, MD5 text address is your friends, so you can see, so that's actually what we're doing with the Patella key. You can see our basic cache key strategy is just put them all in a Patella namespace, then use basically a class name, then the method name, and then a text address of all the args. So this is the way we get any of these. Right? Another issue that we ran into sort of after implementing this was with around expiration. And so this is, Memcached is super, right? But it is really, really simple. And so if you just say that something caches for 4 days, you're going to get cache misses right after that. And that's a little sad. Because we want to be able to use this for things that are sort of high profile, right? It's okay if after a push or something, there's a cache miss. But it would be nice for most of our major pages to load and not have cache misses. But Memcached really doesn't give you any hooks to do that. There's no, hey, I just expired the cache. So our strategy was to add a soft expiry. So this was just one little bit that we also add into all of the results that go into, because everything's going into Memcached through our tool, we can sort of add some metadata around it. And what we do here is we at a soft expiration. So this one here, it's going to cache for 4 days, but then basically any hits on the cache that are on days 2 and 3 are going to regenerate. So it's just going to return, and then it's just going to kick it off again. So basically this way, the only way that you're going to get any cache misses after the very first one with this strategy is if you get one on day 1, and then 4 days go by without anybody hitting it. In which case, let's sort of assume like maybe this is not as big a deal. Like your high volume, the stuff is getting traffic. You should not be having this. All right, next gotcha. Always be JSON. This is a picture of a man getting bit in the ass by not putting JSON in Memcached. This is it's fairly embarrassing. But we've just put objects in Memcached. You're like, oh, okay, let's serialize this into Memcached. We definitely managed to find an object who referenced another object, who had a friend, who had to reference another object, who referenced essentially the entire Rails stack and attempted to serialize that in Memcached. Don't do that. This is not what you want. So the basic key, I think, and this actually solved a number of our caching issues, but by putting it all through Patella, everything that's JSON, to JSON, from JSON, all the keys are strings. It makes it a lot simpler and a lot harder to keep something, but by playing a little fast and most of what you're actually in cache. The last thing I'd say is that the meta stuff is definitely a bit of magic. So it is, I hope it's not that confusing, but it is worth noting that those things are hard to grep. There are a bunch of methods that may be getting called that are not greppable, and you always have to be a little careful around that. But in general, it is I think something important for us. So what does this all look like in real life? What is the net of this? Honestly, I would say it is pretty boring. Basically, round 1, we went in, we put in a bunch of major pain points, some of our large, more challenging queries, more advanced stuff, these sort of things. We went in and sort of did those. But then, sort of round 2 was just looking at performance pages and basically saying, hey, well, does this calculation really need to happen every time? I mean, like, does it really need to be fresh on this request? And can't I just sort of do some magic scaling sprinkles here? And it was really not scaling sprinkles, magic performance sprinkles. And just like, hey, you know what? That little count of the number of notifications that are unread, or that little count of the number of clinical trials you're eligible for, like, guess what? That's not really important, but that always returns an answer. In fact, I don't even need to give you a little spinny that I'm calculating it. I can just not show it, and then on the next page load, it'll probably be there. And so we've been sort of sprinkling those around, and that has been good, fun, and profitable. So pretty much wrapping up here. There is a super alpha version of this gem out there, which has all the code on that, if you're interested in that. And also, we found there's an interesting alternative to this, which you should check out too. It didn't quite work for our use case, I don't think. Honestly, we didn't find it until after we wrote it, so it might be considering that. But it's very Resque. So basically, it just says, it's a very easy way of saying, basically using HTTP status codes to say any method in your app it will sort of like look up in Memcached and then return whatever. It will return a sort of not available and calculate it in the background for you. So it's very REST based, and I think ours we needed a little bit more sort of model stuff, but this is a sort of kind of component. So I'd like to give a shout out to some coworkers who all hopped on this. This is Joe Rodriguez, who did a bunch of helping with the actual coding there. This is Amy, who's here today. You should go find her out. She did a bunch of work on the soft expiration stuff. Keenan helping out putting this all on GitHub to share with you guys. And Winfield was the inspiration for this, so that you wouldn't put it in a sleep. Right. So that's all I have. Does anyone have any questions? All right,
you said JSON. You try to use